All right, so last year when we started this, we started on probability. Now, we did start on some of the concepts that you would have already understood before. I think when you went back to your school after doing commencement here, I'm assuming you went back to school. Maybe you went through some of the content there. I did get you guys to do some work at home. Now, I'm not going to look at that, but I'm not saying that it wasn't relevant, okay? Because a lot of the stuff that we did last year, we're going to look back here as well for chapter 8a, okay? So we're just going to go over a review of chapter 8a, and then we'll go and do some work together. And then if time permits, maybe we'll do some textbook work, all right? But let's see how we go. All right, so as our learning intention for today, and the way that I would like you to follow me when I do this is if I write something down, please write it down as well in the notes. I'll try and keep it as concise as I can. If it's an example that I think is really good and should be written down, try and make some space to write it because it may or may not be in the test or in the SAC. Okay, so make sure you're attentive and you're listening when I'm writing things because it will be helpful. I provided you the notes so that you can write in the notes itself. Okay, that's what it's for. So you don't need to necessarily write notes in a workbook. Just write notes in that really thick page of booklets that I've given you, okay? So our learning intention for today, or what I want to try and get out of, at least for this part of the lesson, okay, is be able to understand, okay, the values, possible values, of probability. So possible outcomes, possible results, possible, things that could happen based on a certain event, okay? And also the level of chance. Now, when we talk about level of chance, we've learnt about words like unlikely, very likely, definitely, or zero chance, okay, or 50-50 even. Okay, that's the levels of chance that you might have. But they can also be represented as numbers. Okay, so I'm going to write that down. It's also numerical. Oop, cannot spell. Okay, it can be a numerical value. Like, for example, 50-50, when you see this 50-50, okay, it normally equals 0.5 as a chance, if you have a 50-50 chance of something happening. If you have something like definitely or very likely, let's use that. Okay, that could be represented as 0.8 in terms of it most likely happening. Or unlikely, these are just some examples. Okay, it could be like 0.2. Okay, we'll be looking at a scale very shortly, okay, about how we get these levels of chance, so these things, and how it relates to it as a numerical value, okay? But hopefully, in terms of what we'll be learning, by the end of it, you can identify what is a chance experiment, and you can associate the level or the level of a chance with some sort of description, or you can associate the level of chance with the number. Okay, so we're trying to connect the word, 50-50 or very likely to some sort of number. Okay, so hopefully that's what you'd be able to do by the end of this lesson. Okay. Also, just a note, you don't have to write everything I do, right? If there's something that you sort of already get, you don't have to write it. Okay, but if you think that it might be helpful, then put it in. Also, as well, and I keep saying that, this will be available to you anyway. So if you do miss anything at any point in time, you can go back and watch this. Okay, so let's continue. So like I said, describing your probability, okay, can be put into a scale like this. Okay, and this is the numerical value depending on what the word is or what the likelihood of that is. Impossible means there's no chance that that thing is ever going to happen. So it's zero. Even chance, 50-50, right there, 0.5, right in the middle. Certain means it's definitely going to happen. Okay, so those words are what we use to describe the likelihood of something happening, and then we can also represent it numerically. And that becomes helpful later on when we bring in the math. Okay, so let's go to the next one. So describing a probability. So whenever you see this PR, it just basically means probability. Okay, doesn't mean parade or it doesn't mean whatever you think it means. PR just means probability. So whenever you see the shorthand PR, it just means probability. And it can be a value between 0 and 1. So it's normally a decimal number because 0 is zero is not a whole number. 1 is a whole number, but 0 and 1 are whole numbers, right? But any probability will fall in between 0 and 1 as a decimal. Okay. For example, the probability of Adelaide Crow will win the grand final last year. Did anyone know who won the grand final last year? Yes.
Demon.
The Demon. So this is definitely 0. Well, it should be 0 because they lost. Okay, but anyway, this person gave them a probability of 0.01 because they were probably a crap team. Sorry to all the Crows fans out there. But that 0.01 relates to extremely unlikely. Okay, so if you go back to this scale here, 0.01 would probably be somewhere here. Oops. Okay, that would be 0.01. Maybe, okay, but definitely close to 0 because it's quite a small number. All right, so very, very, basically nearly an impossible chance. But let's look at some of these probabilities and see if we can put a number to it. What's the probability that it will rain tomorrow? Does anyone know? Anyone know? Tomorrow's weather? Probably. Cold? Did you say cold? Anyone say cold? Yeah, you said cold. I think tomorrow's weather is like 19 degrees. So it's going to be a bit cold. So because it's cold, you know, the chance of it raining could be a little bit high. I would say it might be, okay, it might be on the scale. Where is the scale? You know, it could be likely. So if we say likely, which is around here, what would that be, guys, as a probability number? 0.7. Very good. All right, so let's say 0.7. Okay, what about the probability that Francis will win The Voice with his amazing voice? Do you sing, Francis?
No.
No? Okay, so that means if he doesn't sing, the probability will be 0. Okay, because he doesn't actually sing. Okay, probability that you'll get a 40% or above in your probability SAC. So let's say that you at least pass your SAC. What's the probability of that? I don't want to, you know, just pretend that they're good at math. Yeah, I'm gonna say now, everybody is gonna pass. Yeah, don't fail me during the SAC. So 1 meaning 100%. Okay, well, very definitely likely. Probability you'll be at school tomorrow. This is a hard one because what if you do the COVID test tonight and get a positive? All right, that's a tough one. So who knows? I'm just gonna put 0.5 there. I'm just making these numbers up because just based on the scenario. Okay, but you can come up with different scenarios on based on your own your own situation. Well, let's go to the next one. Okay, but before I continue on, that's how we describe your probabilities. Okay, associating these words, impossible, very unlikely, likely, with numerical values. Okay, we won't really actually be using these anymore. Okay, so these words such as impossible, unlikely, very unlikely, we won't really be using them as much as opposed to the numbers. Okay, so just understand that the numbers will be the ones that we'll use mostly when it comes to doing probability for this topic. Okay, so let's move on to the next part here, experimental probability. So our intention for this is to be able to understand and use experimental probability. Now the key word here is that word experimental. It means that you're going to be doing something, or there's an activity, or there's some sort of test that you have to do to help you predict some sort of probability. Okay, and this is used a lot actually. If you ever want to be in biology or even in psychology, they do use a lot of experimental probability. Okay, they do tests on people and on subjects to see what's the chance of something happening. Okay, anyone doing psych here as a subject? Anyone know there was a really famous psychology experiment where they put a bunch of people in a pretend prison, and then what's the likelihood there? Well, if there's a movie that was made actually about it, it's quite scary. But experimental, just to see what is the probability of people doing certain behaviors based on the roles that they've been given. Okay, but based on what we're going to be learning for this part, hopefully you'll be able to identify what's the chance experiment and what is the event, meaning what's the outcome that's going to occur. Okay, so event can refer to outcome. Or it can also refer to as well, what's the thing that's happening. Okay, And also from there, apply this experimental probability formula. Now this formula, okay, will help you figure out what is the probability, okay? So it's to help you find the probability of an event occurring. Okay, that's what it's going to be. That's what that formula refers to. All right, so let's continue. So here is the formula that we're referring to. The experimental probability of an event, okay, is based on two things: the results obtained and the trial or the number of trials in that experiment. Okay, so you can see here in this formula, you're actually going to be referring to this a few times, and I know there's a lot of words in there, but just think of it as the number of times. The thing that you're really focusing on is the number of times the thing has happened divided by the number of times you've done the experiment. Okay, it's a little bit, it makes a bit more sense when we put it into practice. So the number of times that the event occurred. So let's say, for example, I have a coin and I flip it. Okay, I keep flipping it and I want to get tails on it. Okay, and I flipped it 20 times, but out of the 20 times, I've flipped tails maybe once. Okay, so in that regard, it would be I've flipped tails. Oops, I'll fix that up. Okay, so in that regard, it'll be tails over number of times or number of flips. Okay, if I for example flip the tails once out of 20 flips, then there's my probability right there, 1 out of 20. Okay, using that formula. Let's put it to practice so you can see how it works. Okay, let's do this. And I'm going to pause this now. Okay. Right, so using the formula, you can use these examples as a way to help you understand it. All right, blasting through these really quickly. I just want to see a couple more things. How much have we got left? U1. So we're up to this, guys, theoretical probability. But I'm just going to move ahead a little bit. Okay, I might skip through some of this because they might not be very applicable. All right, let's look into theoretical probability. Okay, and this will be one of the last ones that we go, and then I'll let you guys do some work. So this one here is be able to, what we want you to be able to do is calculate the probabilities for equally likely outcomes. Now there's a keyword here, equally likely, okay? Equally likely meaning they both have an even chance of occurring, okay? And understanding, and I mentioned this before already, what is a complementary event? Another word for complementary, and I'll put that, I would suggest you write this here, opposite. What is the opposite event, the opposite thing that's happening? Let's say, for example, the opposite of me waking up is what? Falling asleep, okay? Or the opposite of me showering is not showering, okay? Or the opposite of your of pants, for example, might be shorts, okay? So complementary just means the opposite of that event. Opposite of winning, losing. Opposite of yes is no, okay? So based on this, what I want you to be able to understand is what is a chance experiment. Apply that experiment using that formula that remember we learned about just then, and then apply this complementary rule, which we'll get into. Okay, so theoretical probability is the probability, again, it's actually quite similar to the previous one. Probability of an event, and it depends on the number of favorable outcomes. Okay, it's quite similar to the previous formula that we learned about. So the top number is always the thing that you want or the thing that has happened. Okay, and then the bottom number, you think of it as all of the possible outcomes or how many times that thing, that experiment occurred. Okay, so it's very similar in terms of the formula. Don't get them too mixed up though, but they are quite similar. So they're interchangeable. We're going to skip this. Let's say, for example, okay, rolling a dice. What is the probability of rolling a 4 on a dice? So remember on a dice, sorry, I've skipped one slide. On a dice, you've got 6 numbers. Okay, so that means if you have 6 numbers and one of them is 4, and it's written there already, always start off with what are the outcomes, possible outcomes? Well, there's 6 numbers altogether. And what's the chance of a 4 occurring? Well, there's only 1 4 in a dice. So 1 in 6 chance of getting a 4. Let's try this. What about the PR? PR of an odd number. Okay, what's that? So if you have 6 numbers in the dice, what's the probability of getting an odd number? 3. That would be 1, 3, and 5. Okay, so 3 out of 6. Okay, so that would be a half. Okay, now if I asked you, does anyone know what this means? PR odd with a dash on the top. What does that mean?
Anything but odd.
It's a what, sir?
Anything but odd.
Anything but odd, which is, what is that? What's that word that we learnt about? That's opposite. Complementary. Okay, so the thing that's opposite to the odd would be even. So if you ever see a line like this, PR odd with a little dash like that, it means it's the opposite, or the complementary. So in this case, PR complementary of odd, which is even, would also be a half. Okay, the opposite. Okay, let's try this. PR of, let's go, if I flip a coin, PR of heads. Okay, what are the 2 options for a coin? Heads or tails, yeah? So you've got 2. For the bottom, top number, okay, how many heads are there in a coin? Normally 1, okay, so a half. Now, if I did this, PR, heads with a dash, what would that be? What's the opposite of heads? Tails. So it'll also be a half, okay? So just understand that that little dash means opposite or complementary. Okay, let's go to the next one. Okay, what is the probability of not rolling a 4? Okay, so remember, we had this before. PR of 4 on a dice, okay, was 1 over 6. That means if you were to represent this, now it does represent it as a, as a roll a4. Okay, that doesn't make sense. This should be a dash here. Okay, but basically, remember, if you see PR of not 4, think about it. How many numbers are not 4 on a dice? 5. You got 1, 2, 3, 5, 6. So it should be 5 out of 6. So the opposite of 4, in that case, would be 1, 2, 3, 5, and 6. So there's 5 numbers. Okay. And one thing that you have to understand as well, so when it comes to probabilities, if I had the probability of 4, so I'll write this down here actually, PR of 4, okay, plus the PR of not 4 would equal 1 over 6 plus 5 over 6. Okay, and that equals, that adds up to 1. So you'll notice that if you have an event and you add it with its opposite, it always equals 1. Okay, keep that in mind. All right, I'm going to skip this. And I've sort of mentioned that here. Okay, so if you have an event and you add it to another, it's complementary, it always equals 1. Okay. All right. Let's keep going. Let's look at this one. And I think this is the last example, and then we'll do some work, okay? So here on a deck of cards, a card is drawn, okay? And we are looking at the probability of these events happening. So the probability of a spade, right? So let's look at that, a spade. I'm going to do, there's a lot of words there, but you can look at how I do it here so you can see how it's done. So PR of a spade. Okay. So guys, how many spades are there in a deck? 13. Very good. And how many cards are there altogether? 52. Good. And then what's that simplified? 1 over 4. Good. Okay. So that means if the probability of a spade is 1 over 4, what's the opposite when you go probability of spade complementary? So complementary of a spade. So what are the cards that are not spades? How many would that be? 30. Anyone know? It'd be 39. Okay. 39 out of 52. Okay. And then that simplified, does anyone know what that's simplified as? 3/4, yeah? And notice, again, how if you look at that formula, PR of spade plus PR of complementary of spade or not spade is going to be 1/4 plus 3/4. Okay, and that always equals 1. Okay, so understand that an event, can you guys see that? Hopefully you can. An event plus its opposite is always going to equal 1. Okay, so keep that in mind. All right. I think that's it for me. I'm going to stop now.